Hey everybody. In this next video, we're going to put everything together that we talked about in the previous videos about polynomials to sketch the graph, okay? So the first thing we want to do is, looking at this graph in the form that it's in, we can determine the end behavior. The end behavior of this graph is determined solely by the leading coefficient, or the leading term, and the degree. So since this is an odd degree polynomial with a negative leading coefficient, my end behavior is going to be that I start high, sorry, that was messy, that I start high and I end low. So I'm just going to do a rough sketch down here, and then I have graph paper on the next page that I'll use. But basically this graph is going to start high, end low, okay? So I know these pieces are in place, okay? And I don't have a scale here, so this could be as far to the left or to the right as we want it to be later on. Okay, also in this form, I can find the y-intercept really easily. There it is. So I know that the point 0, 16 is on my graph, because if I plug 0 into this function, f of 0 will give me the y-intercept. And when I plug 0 in, all these terms disappear. And so I just get 16. So 0, 16 is on the graph. Okay. Kind of like with quadratics, same thing here. This is just a higher order polynomial. And just like with a line, that constant term was also the y-intercept if it was in slope-intercept form, which would be along the same lines of this form of a polynomial. Same idea. But now I also want to know the x-intercepts, okay? And the x-intercepts, I'm going to need to factor in order to find them. So I'm going to set negative x cubed minus 4x squared plus 4x plus 16 equal to 0. I'm going to group here because I have 4 terms, so I'm going to factor out a negative x squared out of the first 2 terms, and that leaves me with x plus 4. I'm going to factor a 4 out of the second 2 terms, which leaves me with x plus 4. And now I can factor an x plus 4 out of both of those terms, which leaves me with 4 minus x squared. And this is the difference of 2 squares, so I get x plus 4, and then I get 2 minus x, 2 plus x. Okay, and I wrote it this way because otherwise people might not see that there's 2 different answers here. So if you had written it x plus 4 times negative x squared plus 4 equals 0, and then you set each term equal to 0, you get x plus 4 equals 0, which gives you x equals negative 4. And then when you set negative x squared plus 4 equal to 0, you get negative x squared equals negative 4. So then x squared equals 4. So x equals plus or minus 2. And people forget the plus or minus, so they miss out on one of the x-intercepts. So if you have it in factored form like we have there, we can see the 3 factors. We know that x equals negative 4, x equals 2, and x equals negative 2. Those are my zeros, so I would write them as ordered pairs because I'm going to put these on a graph. Okay, so at negative 4, I have a 0. At negative 2, I have a 0. And at 2, I have a 0. And you can see that the multiplicity of each of these zeros is 1, and there's no extra exponent here. So the multiplicity of each of these zeros is 1, which means that I'm going to go through the x-axis each time. Now, knowing the points that I have plotted here, knowing the end behavior, the y-intercept, and the x-intercepts, it's going to give me a pretty accurate picture of this graph. Here we go. I have to go through, 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 and then I can do a little fanciness to get over to there. That part's not necessary, okay? and I'll show you in the more accurate graph. But this is the only way I could have drawn this to connect all the dots. I can't go through the x-axis in any other spot but these 3 spots, and I can't cross over here and loop back around because then this fails the vertical line test and is not a function. I can rework my end behavior over here so that this is just going straight down, and I'm still starting high and ending low. This is what my graph's going to look like. But let's do it a little bit more accurately. Okay, so I have my coordinate plane here. So this is x, this is y. I'm going to go up by 1s in both directions. Actually, in the x direction, I'm going to go, I'm going to do every other line is 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16 is here. I'm going to plot, let me just double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 16, 0. So that's my y-intercept. 2, 0 is here. Negative 2, 0 is here. Negative 4, 0 is here. Okay. And it doesn't matter sort of the shape. I just know I need to start up high. So I'm going to start up here. It should be a nice smooth curve. Shouldn't have any sharp edges or anything because it's a polynomial. I need to go through this point and then back down through here. You can see I'm lifting my pencil. This isn't the greatest thing ever. And you can always check your answer on the calculator just by plotting this, just to see if you're getting the right basic shape. So there it is. There is my polynomial function. So let's go ahead and do one more. And I'm going to do all the basic information, and I'll do a basic sketch, and I'll leave it to you to make a more formal graph like we just did here. Okay. So again, just looking at this, it has an even degree. It's 4th degree, so it's even degree. The leading coefficient's 1, so that's positive. So my end behavior is going to be as x goes to negative infinity. So I start high, and I'm going to end high. Okay, so my graph, if I'm doing a basic sketch here, is going to start high, it's going to end high. Okay. I don't have a constant term at the end of this, so the y-intercept is going to be a 0. It's going to be 0. It's going to be one of the zeros as well. So let's just go ahead. The y-intercept is going to be 0, 0. I can already plot that, but that's also one of my zeros that I'm looking for. It's also one of my x-intercepts that I'm looking for. So to find the x-intercepts, I'm going to factor. So I can factor out an x squared, and that leaves me with x squared plus 5. If I set this equal to 0, I get that x equals 0, and I get that x squared plus 5 equals 0. So that means x squared equals negative 5, and that's impossible. I can't square a number and get a negative. So the only real 0 is the one that I already plotted. Okay? But this is a 4th degree polynomial. So there's a couple things that could happen here. I talked about how the most x-intercepts you could have is equal to the degree. So in this case, I could have had at most 4 x-intercepts, but I only have 1. It also turns out that the most number of times that a polynomial can change directions is 1 less than the degree. So this can change direction 3 times. And what I mean by change direction is go from decreasing to increasing. So that's 1. I went from decreasing to increasing. So I could come back down here. I could hit this x-axis, which this 0, 0, 0 has a multiplicity of 2. Okay, so I'm going to touch the x-axis and go back up, and that could be one way that this is graphed. Okay, another way this could be graphed is I could go down, bounce off the x-axis, and do that curly thing on the other side. I could also just go down and touch the x-axis and come back up. All of these would be correct answers in my eyes because you wouldn't know any different. But on Pearson MyLab, just make sure that you have all this information, that you found the end behavior, you can do all of this, and you have a basic idea of what the shape is, and then you can test out some points, or you can just graph it in your calculator to see if it does some of this weird stuff here. But this right here is not something that I'm worried about. That's what you're going to find out how to do in calculus. And so I'm not that concerned. Okay? And I will definitely take that into consideration when grading or reviewing your assignments on Pearson. All right, so that's all I have for you for polynomials, and I'll see you in the next set of videos for rational functions.